Imagine that Albert is sitting in his car on an inclined plane. You want to find all the forces acting on him to keep him located in that position. No longer is he on a flat, he's on an incline. So no longer do we use the x and y axes parallel to the ground and to the vertical. We're going to tilt those axes so that the x-axis is parallel to the incline and the y-axis is perpendicular to the incline. So the x and y are still perpendicular to each other, but no longer horizontal and vertical. Here are some numbers we can work with. 20-degree angle for the incline and a 3-kilogram mass for the car and Albert. First force you know has to exist is the weight. And the weight is vertical. It's parallel to the edges of your paper, not parallel to the x or the y axis anymore. It's still straight down. That mass of 3 kilograms times 10 newtons per kilogram gives you 30 newtons. And the angle, that 20 degrees, is the same angle as the angle with respect to the horizontal for the inclined plane. And just as with every other time we've ever dealt with a vector not parallel to the x or y axis, you have to draw the vector component triangle and find those vector components. Albert is sitting on that incline, and part of his weight is pushing him into the incline, perpendicular to it, and part of his weight is pulling him down the incline, and that's what we're finding here. The W parallel is the component of force pulling him down the incline, and the W perpendicular is the component of the weight pushing him into the incline. Hypotenuse cosine angle and hypotenuse sine angle give you those two components. Turns out to be 28.2 newtons and 10.3 newtons. What holds Albert on that incline? It's a friction force, parallel to the incline acting up and to the right. And finally, the normal force, which is important for the friction force, the force perpendicular to the surface acting on the object along the positive y-axis. And now by inspection, knowing that this is static equilibrium and the forces in the x direction balance and the forces in the y direction balance, you can fill in the rest of the free body diagram. Shown here is another way to draw the weight component triangle. I tend to avoid it so as to provide more space for drawing forces along the x-axis parallel to the incline. And finally, a third way for drawing the components of weight on this free body diagram. All three of them are legitimate and each of them has advantages and disadvantages.